Good evening, everybody. Hope everybody had some pizza and all that. My presentation is going to be like 10,000 feet above from where he was. It's going to be like Steamboat Willie after like watching Godfather. So this is going to be fun, because we're going to be talking about a particular aspect of Gen AI development that's happening pretty much across the board, where we all acknowledge that 80 to 90% of data is unstructured data across our enterprises, right? So one of the things that enterprises are struggling with these days is extracting structured information from that, PDFs mostly, images as well, and getting those out in a very meaningful way, right? But the most important thing is there are two elements that will drive what kind of tooling you use. One is accuracy, the other one is cost. So between these two, will determine as to like how or what approaches we take, what kind of tools we choose and all that. As a way of introduction, my name is Dinesh Chandrasekhar. I run a company called Stratola, through which I enable a lot of startups. I'm a fractional CMO at Unstract, which is whom I'm representing today. I'm talking about it. If you wish to connect with me on LinkedIn, please feel free to do so. That QR code should take you there. So. And I have a wide range of experience in the data, AI, and automation space, so happy to chat with you offline as well. So first off, let's address the elephant in the room, right? So when I say document trouble, what does it actually mean, right? PDFs come in all kind of formats. Scanned PDFs, traditional PDFs that have been generated, PDFs that are from a particular system, transported PDFs that have been attached together, all kinds of stuff, right? And manual extractions take a way lot of time, particularly when you talk about RPA and the intelligent document processing kind of modes and all that of extracting data. It takes a lot of time to extract data. And they may not be immediately available. Like unstructured data is not going to be immediately available for real-time analytics that you need in your enterprise. Most of the data is sitting inside the PDF, so it takes a little bit of time to extract that and put it into your system for you to actually use it for analytics. And most importantly, errors, which is why I talked about accuracy, right? So errors are introduced by even having humans in the loop, right? So when they look at the PDF and copy paste or look at it and type it into a different screen, you are introducing errors. So you want some kind of automation that makes sure that you can not only extract data, but also automates this very, very effectively. I mean, the challenges are obviously, you understand this, right? So there is subpar product experience, there are cost implications, there are accuracy implications which lead to brand questionability and all that kind of stuff. So what does Unstract do, which is what we are talking about here, right? So I'm going to use this as a mechanism to show you a demo and all that stuff. So I have only a few slides, so bear with me. With Unstract, what you can do is you can ingest any number of large PDF documents, right? So there is no limitation in terms of what kind of PDFs you can ingest and what size and all that kind of stuff. And you can convert obviously that kind of unstructured data into structured data. And it's not just taking the raw text as is, but you can also query it, interact with the document, and extract what you need from it. And a way of doing that is it leverages LLMs. So you can pick and choose which LLM you want for your needs, and you can use that to extract the data as well. By way of which, again, you are addressing all the challenges that I spoke about earlier, right? So cost implications and the automation piece of it, as well as the instant business insights that you need for these kinds of automations. In terms of brief history of document extraction for people that haven't been following the space, earlier techniques were predominantly OCR, right? So that's predominantly what we used to have. And I mean, OCR still exists in a lot of places, but OCR is considered to be legacy in terms of technique for extracting this kind of information. It practically scans it and extracts that data. The second generation would be more ML based, where you can indicate XYZ coordinates and say, here's where the particular data is, here's what you scan, and here's what you get, and all that. You can indicate and teach it. But once the format changes, it crumbles, right? So that's the other challenge. The third generation is where we are right now with LLMs, right? So now LLMs actually can understand a PDF the way humans do. They can read the text and parse it and make it more meaningful for you to interact. When you say in a credit card statement, get me all the line items or transactions that I've had in the last month, it will be able to interface that and get that out for you, right? So that's kind of the level of interaction that I'm talking about here. Unstract is tech agnostic, so you can basically use any LLM provider you want, any type of vector database you want, Milvus including, any type of embeddings and text extractors, right? So you have all of that. Unstract has its own text extractor called LLM Whisperer. You can check it out. It's its own capability. It's actually pretty solid, and that's what drives this whole technology here. But the predominant part of the prompt engineering tool that I'll be showing is open source, so you can also go to the GitHub libraries and download it and play around with it as well. So, two phases of processing that I'm going to be showing. One is the prompt engineering phase, which is where I will show you a PDF and I'll write prompts and actually get data out of that structured PDF, unstructured PDF. And then a deployment phase where that same thing can be deployed as an API. And now I can use this API practically in anything, right? So if I'm building an automation tool, having my own GenAI application, anything at all, I can use that API. So demo time, right? So I said very minimal slides. I actually had a thing to say about RAG, but because we had a fantastic RAG session, I'm not even going to go into explaining what RAG actually means. I think you got a gist of what actually RAG does, right? But in this case, I'm going to be using Milvus as a part of this demo. So I kind of put Milvus in there and kind of tried to show you this. The only thing that I'm going to talk about is the structure that I'm going to demonstrate. One is I'm going to show you how to actually get data out of this PDF without using a vector database, right? And it'll matter. It'll matter because when you use smaller PDFs, let's say a 1-page, 2-page kind of a PDF, it'll be very easy, very quick. LLMs understand as long as the document is not super complex, it should be able to fairly understand what data is there, how to extract it and all that. But when you have let's say a 100-page PDF, 200-page PDF and all that, that's when you really need chunking. You need a vector database. You need to be able to take chunks out of it and put that into a vector and have the vector actually do its thing. So I'm going to show you both, right? And you're going to see the benefits of using a vector versus not and all that, right? So in terms of, again, cost and accuracy. So that's what we're going to do. The one thing that I'll point out is when I'm using the vector, I'm going to be using two retrieval mechanisms. So one is a simple retrieval mechanism. The other one is a sub-question retrieval mechanism. I'll get into it and then I'll show you what that actually means. So let me switch into no, that's not what I wanted. There you go. How do I get out of this full screen mode? It's not coming out. There you go. All right, so this is the Unstract prompt engineering tool that I was telling you about, right? So this is called the Prompt Studio. And what I have here is a bunch of projects that I built, right? And what I mean by a project is, I'll show you in a second, I built a few.
Could you increase the font size at all?
Yeah, when I get into a particular thing, because once I zoom in, it'll be harder. So let me get into a particular project and then I'll do it. So I'm going to pick this project which says 10Q parser. A 10Q is a document which is a complex, company document that gets submitted to the SEC every quarter and so forth. I'm going to be parsing that without a vector database, right? So I'm going to pick this. And what you'll see here, that's as good as I can get, sorry. What you see here is different prompts that I've written. So I'm just saying, what is the name of the registrant specified in this particular context? What is the commission file number and things like that. These are actual prompts that I'm writing, no code, nothing, right? So I'm actually prompting into this, and it is querying the PDF. The LLM behind is querying the PDF, and it's getting the data back for me. Now you might ask, which LLM am I actually using here? I'm actually using two of them, right? So there is one GPT-4o, the other one is a Claude 3.5 Sonnet. And both of them are kind of getting me comparative results of one is saying Apple, the other one is saying Apple, obviously, and I'm using an Apple 10Q document here, so that's what it's doing. It's also showing me the number of tokens this one is used and the cost it's used and all that, right? So there is a same thing here. That's what is happening. And you can see the cost difference between using Claude versus this and all that. And you can evaluate this. As you go through it, you're going to kind of evaluate all through this, the complexity as well. For example, here I'm using a JSON output instead of just plain text. I'm saying, get me a JSON output, and I want like the full address, city, state, zip code, and all that. And it'll also be able to like format it as a JSON. Again, plain text, that's what I'm like, doing here. Now, when I do this, and what I can do is I can actually deploy this as an API, and I do already have it deployed as an API. And you can go in here and practically download a Postman collection from that. And I have Postman set up here. And let me just process the same 10Q parser without vector DB thing here, right? So, and if I use an Apple 10Q document here, you can actually use any 10Q document. As a matter of fact, it doesn't have to be an Apple 10Q. But in this case, I have a different version. It's a Q2 version, while I tested it or built it originally on a Q1 version. It has actually given me the results, right? So the API came back with the results here. All the text that you saw earlier in our output is like all here, right? So what I'm going to do is I'm going to like scroll to the bottom here to show you one quick thing before we jump into this. This is the section. Let me zoom in here a little bit so you can see. So if you see here, you can see the cost in dollars for the overall document for all the prompts that I gave, right? It's showing me it's $1.4. That's the total cost. The input tokens and the output tokens, everything is listed out here, and it's used GPT-4o, and that's the output here, right? It took me $1.40 to process the document for all the prompts that I gave in. This is without using a vector database, right? So that's what I want you to remember. Now, going back to Unstract, in the same prompt studio, if I now pull up one with vector DB, right? So this is a simple retrieval. So in this case, what I've done here is, if I go into like settings here, you will see that I'm actually using a vector database in this particular case. In this case, it's Milvis, right, on Zillis Cloud. That's what I'm using here. And I've set it up. And if I go into the edit mode, you can also see the chunk size that I've set up, the overlap that I've set up, everything is set up here. And the retrieval strategy is also indicated here, in a simple versus sub question and all that. So I told you I'll talk about it, right? Simple is practically saying, send it as is, right? So without like changing anything, or like submit the query as is and get whatever the vector DB gives you, right? So if I say ask for address, it's going to ask the vector database for all the chunks where address is, and it's going to return me all the chunks, and I'm going to get all of that, right? The sub question part of the retrieval or that strategy would be where it recursively iterates and gets me only those chunks that are relevant and eliminates the duplicates, and it's more accurate than this, and I'll show you how, right? So in this particular case, same thing, right? So same kind of question, a different 10Q here, and I'm asking for like the same kind of questions. What is the registrant's name, commission file number, and all that? It's giving me the same results now, regardless of what I'm using. It's a fairly accurate. And if I go to Postman here, and if I look at the other one here, I have already executed it, so for the sake of like time, I'm just going to like talk about it. It's showing me the same thing with the vector database, the same document, the same Apple 10Q document that I showed you, executes at like 17 cents, right? So what was originally like $1.40 without like using a vector DB, now is showing me at like 17 cents, right? So that's the kind of cost effectiveness that you're seeing here, right? And the accuracy, again, will also like improve. The more and more complex queries you start using, you'll see more accurate results returned back as well. And while I'm here, again, in the interest of time, let me also pull up this sub-question retrieval thing that I was telling you about. And in this particular case, the results are going to be with, again, 23 cents, right, in terms of cost. It's leveraging the vector DB, but it's, again, doing that recursive querying of asking this. The recursive querying actually helps when you have like a really complex prompt. And I'll show you an example of what a complex prompt looks like. Because in this case, I'm actually asking like one prompt at a time, which means you're hitting the LLM every single time there is a prompt here, which is not the most ideal, pragmatic, practical way to actually do it, right? So what I would want to do is consolidate all my prompts together and then send it to the LLM, and which again would leveraging the vector DB actually makes more sense. So in this case, let me show you what one such thing looks like. So let's say I've created a compact 10Q parser question with sub-question retrieval. This would be, let me just make it a little bigger. So in this case, what I've done is I've practically consolidated a lot of those prompts into like one single prompt, right? So I've just said, create a JSON object, get all the disclosures, get all the income details, get all the risk factors, everything, put it into this particular format, right? So this is not easy enough, because when you say risk factors, it has to like look through this 90-page document, and it has to understand where and all risk factors are, put it all together in a meaningful format and all that, right? And so when you look at how GPT-4 and Claude came back with the results, you will see that each has a different way of like returning the result. One says foreign currency risk and talking about it in a certain language, versus like Claude using it in a different way and so forth, right? So both are going to be like very different in terms of that. And in this particular case, we're actually seeing values when it comes to, because I use the sub-question retrieval, it is actually going in for like, complex questions like, get me all the income details across like different quarters in the particular 10Q, right? So it goes in, looks for the current quarter, what the net income was, what the quarter name was and all that. And it does that the same quarter comparison from last year and all that, right? So these might be in different pages, different tables that span across different pages. These are like really complex formats that are not easy to format or query with like, OCRs or like, traditional techniques that we've been using. And this is why like LLMs are like, super powerful when it comes to like, handling it. The same compact parser, if I use, let's say, the simple retrieval technique, you will see the difference is that the format is the same, right? So I'm using kind of like almost the same long format. I'm like, giving it all that. But at the end, I'm also like saying things like, more instructions, hey, return a JSON object, not a JSON array. Any income reported should be returned as a number with no formatting, blah, blah, blah. So I'm giving it a lot more instructions. This is not easy for VectorDB to like, process unless or until you kind of like break it down into like individual prompts. So you need to use the LLM to like make this complex prompt into like simpler prompts and then send it to a VectorDB. But if you use a simple retrieval strategy, it doesn't do that. And the result you will see here is it actually returns nulls for a lot of things, right? So net income, it returns a null and all that, because it's not able to understand how it is able to like, get that data, how it is supposed to format it and all that. So it fails that, right? So my point is that a combination, the right combination of using this kind of a tooling like Unstract with VectorDBs actually produces like phenomenal results when it comes to accuracy and cost, which are like the two important factors that you want to consider when you're treating this. So quick show of hands, like, while I jump into the last part, how many of you are like, involved in projects that deal with like unstructured data or extracting data from unstructured? Like quite a few hands, good. So would love to like, talk to you after the session as well, about like, any other things that you're facing in terms of challenges and stuff, and how this felt or resonated with you, and if I can help you in anything else. Take a look at the tool. As I said, it's like open source, download it, play around with it. There's free trials and all that on the website as well. There are mechanisms that you can leverage this for, right? So you can set up your own LLMs, whichever LLM you want. We support like, pretty much all major ones. Any kind of vector DBs you want, embeddings and text extractors that, you can use all of those. Customize it and play around with it. And let me know while I jump back to my demo in the last thing and show you this, right? So this is the two things that I spoke about, the simple versus the sub question. So again, if you have more questions, you got a SME that you can talk to as well. But I'll be happy to like chat about this. And summing up what I showed you, right, in terms of a full document that I submitted as is without a vector DB cost us like $1.40. Accuracy is good, but at the same time, it's not going to be cost effective, particularly when you're dealing with like hundreds of thousands of documents that you need to process on a daily basis. Think insurance industry, financial services industry, and so forth. Simple retrieval, lowest of the lot, very cost effective, but the response or the accuracy is not like that great. But sub-question retrieval, obviously accuracy is like very high, And it could be like, expensive than the simple retrieval model, but not as expensive as like setting a full document access, right? So context windows, number of tokens, everything matters when it comes to like, processing this. A lot of us don't think about it that deep unless or until you start processing it at scale. So that was the whole point of the topic here, that it is about extracting data, structured data from unstructured files at scale, and leveraging tools like this. Okay, hopefully that was helpful. I got like links and stuff, and you're welcome to like click them. I think once they send the slides, you can click them and download it and do stuff. That's a QR code to the trial page if you want to like take a snap and all that. So thank you.